My name is Nicholas Grace, and I'm going to be going over the electromagnetic spectrum, what it consists of, how the different frequency in it, just all different things that's made up of the electromagnetic spectrum. And I'll be going over it in my PowerPoint I have presented here for you today. What is the electromagnetic spectrum, you might ask? Well, the electromagnetic spectrum is the complete spectrum or continuum of all forms of different light. The electromagnetic spectrum has different waves which consist of electric and magnetic fields which will vibrate, thus making the waves in the different wavelengths you see in it. And it is consisted of different ones, and here they are. We have the radio waves, the cell phone waves, to the microwaves, radar waves, to the infrared waves, the visible light waves, the only one that a human eye can actually see, to the ultraviolet waves, the X-rays, and then gamma rays. And next we're going to move down to how you define it. Well, it's defined as the properties of electromagnetic waves, which include speed, frequency, and wavelength. Speed represented by S, frequency by F, and wavelengths by the symbol I have on here now, which I don't know how to pronounce it and I don't want to butcher it for y'all. So, and are related all in this formula here. I have S equals F times the symbol. So it's speed equals frequency times wavelengths. And all light waves travel at a speed of 3 times 10 to the 8th in a vacuum. Now the relationship between wavelengths and frequency are all parts of the electromagnetic spectrum travel at the same speed. Therefore, wavelength and frequency have an indirect relationship. This means that as one characteristic increases, the other decreases. So in other words, as the wavelength increases, the frequency will decrease at the same time. So it works in tandem. Then we have the wavelength, frequency, energy. So electromagnetic wave characteristics are: short wavelengths have a high frequency, and long wavelengths have a low frequency. While electromagnetic waves and energy, the high frequency waves have a high energy, and the low frequency waves have a low energy. And here I got a picture pulled up for you, you can tell. Going from here, from the longer to the shorter, and it all travels the same way. You get right here the longer one, it slowly gets smaller wavelengths while it's increasing the frequency and energy across. And you got the radio, microwave, infrared to the visible, which is highlighted in red because that's the only one we can see, ultraviolet, X-ray, then gamma ray. And here's another picture, a better one. As I said, we can see this one, the visible, right here in the middle, and these are about the different size: building, human, honeybee, pinpoint, protozoans, molecules, atoms, the atomic nuclei. And then I got the different frequency: 10 to 4, 10 to the 8, 10 to the 12, 10 to the 15, 10 to 16, 10 to 18, 10 to 20. Then I got temperature of the body emitting the wavelengths: 1 kil, 1 K, 100 K, 10,000 K, 10 million K. Then I'm gonna go over what they are and what their formula. So microwaves, longer than radio, shorter than infrared or visible light. Wavelengths 1 times 10 to the negative 4 to 1 times 10 to the negative 1. They're used for communication, medicine, and consumer use microwave ovens, which I'm assuming all y'all have one at home, which is something that's beneficial with microwaves. And you got the radio waves. They're low energy waves with long wavelengths, which include FM, AM radar, and TV waves. Wavelengths of 10 to the negative 1 and longer. Low frequency, used in many different devices such as remote control item, cell phones, which I know all y'all probably have one in your pocket right now if you ain't using it. And then you got wireless devices, and they go on. And we use all different types of the way you use it all, and it benefits it greatly. We have infrared waves, which is invisible electromagnetic waves that are detected as heat. And it can be detected with special devices, one such as night vision goggles. You have infrared scopes, different devices. I mean, it benefits. It's really great. The military really uses this type of stuff. Also, they're used in heat lamps. I mean, and they have a higher energy than microwaves, but lower than visible light does. And that's we go on to visible light. It's the only portion of the electromagnetic spectrum in which a human eye can actually see it. The human blind eye, this is the only one we're able to see for ourselves. And I got the different colors here in the form. Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Which color has the lowest frequency? Red has the lowest frequency. And which one has the highest? Well, violet has the highest, the opposite end. And here you got a diagram of the visible light. This is where it consists of right here, from the visible light to the red. And you got all the different, in the color spectrum, you can tell all different colors. And we have ultraviolet waves, which is higher energy than light waves. Can cause skin cancer and blindness in humans. And it's used in tanning beds and sterilizing equipment. So just remember that the next time you're getting a tan, you also might be possibly getting skin cancer. Then we have X-rays, high energy waves used in medicine, in industrial, and astronomy. But in medicine, it's really great. I mean, it helps for you can see your bones, so that way they know what they're actually got to look. But the bad part is it can cause cancer. But that's over a long period of time and constant use of it over and over. Next, we go on to gamma rays. It's the highest energy however, it's blocked from Earth's surface by the atmosphere, which is really good. Otherwise, none of us would be standing here today because we all be burnt up. And then I have another diagram here for you. And it just shows everything again, from the radio to microwave to infrared, visible light, ultraviolet, X-ray to the gamma rays, and how it goes from the longest to the shortest. And then we got the approximate size again, football field, humans, and just keeps going, shrinks all the way to atomic nuclei. And again, here's the color spectrum, red to violet, radio, microwave, and then I got the frequency of it in hertz. And that's going to be my PowerPoint today. Thank y'all.